Good afternoon, everyone. Uh, Everyone can see my screen okay?
Yes, sir.
Okay. Well, I hope you all had a good weekend. Happy to be back at school, I'm sure. Um, but anyway, so let's get started on. Well, first off, is there any questions on the module or assignments so far?
Yeah, so on module one, like on our grading sheet that we can see on Canvas, it says there was two module one quizzes, and I wasn't for sure if that was just an accident or if I didn't take one of them.
There's only one.
Okay.
So let me check into that. I don't understand. Because actually, when I looked at it, the grade book and everything, I only saw one. But I'll double check.
Okay, thank you.
But for sure, there's only one. And actually, I'm pretty sure everybody completed it. Yeah, because I went through and yeah. So okay. Any other questions? All right. Well, today we'll kind of get started and talking about material handling systems. What is a material handling system, and then actually how to start developing a design for a material handling system. So, material handling system, excuse me, just a integrated system that interfaces two or more material handling devices. So, you kind of based on that definition, a system can be very small. There's just two or more material handling devices, that bridge the gap between workstations. All right. Um, so the goal is being a high degree of mechanical coordination and precise movements between the workstations. And a material handling system, you're looking for the concurrent automation of information flow with the physical flow. Okay, so you want the you don't want to be a lag when like information's there and people are sitting and waiting for the the physical or vice versa. So the concurrently, so for everything to be arriving at the right place at the right time, it would be a good system or a characteristic of a good system. Um, so a integrated system be characterized by unbroken, highly coordinated material flow. In particularly, in manufacturing and warehouse operations where continuous flow is emphasized and delays, waiting, and intermittent storage is minimized. Now we'll talk a lot more about that as we go through this, and then we get to the value stream map. We'll talk about, we'll look at how to map the flow and how to create this continuous flow of information, material, and product. So, as you know, everything you see in a retail store, has gone through a material handling system. Even the shelves that the items for sale, the shelves themselves all went through a material handling system to get there. So everything in your supermarket or like I said, any retail situation, as we already stated, if it's in the supply chain, it's got to be moved, and what's going to move it? It's going to be a material handling system. It's kind of redundant here. It's just most things you come in contact during your life have gone through a supply chain. Uh, and which is a supply chain is enabled by a material handling system. So, supply chain, is a, uh, what it is actually the map or the path that a product takes from the factory to your doorstep. All right. So just the route that item takes. That's what the supply chain is. But, it goes all the way back to the raw material state. So supply chain consists of several different stages. Uh, starting with the raw material, through suppliers, to the factory production, distribution, and everything. From manufacturing to consumption, the process is performed by material handling. And again, supply chain is path product takes to get to you. So just reinforcing, the importance of what material handling system is. Then also you got the last one here, being the cradle to the grave. So after it dies, after a product, doesn't have any more use, what happens to it, and how do you get it to the right place to be disposed of properly? And and with more focus on environmental concerns, this will actually be a growing issue, and it's also often called reverse logistics. How do you get it back to the to the factory to be to be refurbished or reused or whatever. So, designing the material handling systems requires you to break the supply chain uh, to its major function activities. All right, so you got we raw materials going to the factory, going to distribution, going to the retailer, going to the customer. Yeah, but the factory and distribution functions utilize the most variations of material handling techniques and equipment. All right. So, in suppliers, raw materials, the retail, whatever, you definitely have, different material handling techniques and equipment. But in a factory, and also as you've seen on some of the videos in the distribution, that's where, most of the material handling is happening. And definitely, I mean, the variation in material handling. So, the kind of key what we're going to look at here is actually how to really analyze what the material handling system design should be, and it needs to be designed on a factory level, or actually not just a factory level, but on maybe a assembly line area or a functional area of a factory, like fabrication or packaging or testing, whatever. Uh, but then once you get these mini systems designed, then you want it all to be one, major or integrated system that covers the whole factory. So you'll have a factory system, but it'll be made up of sub material handling systems. So just a little bit more redundant here, just keep thinking about it. Material handling means providing in the right amount of the right material in the right condition, the right place, right position, right sequence, right time, right price, right method. Whoops. The right method. Okay. So, stuff we've been talking about before, but again, the materials handling has to make all this happen. It has to be synchronized, and particularly with the right information flow to make sure that all this is correct. Here's another set of numbers, and these numbers I don't want you to take as just being these are hard fact numbers, but the reason I'm showing this comes from another report, study, but I just want you to think about how big of a deal material handling is in the manufacturing factory. Okay, so these numbers are from a validated report, but I mean they change over time, but it's still a good rule of thumb. 25% of the total workforce is used in material handling. 55% of the factory floor space is reserved for it. Now, a lot of that, of course, will be storage, but that's still material handling. 87% of the total production time, is being accumulated in by material handling storage function. Okay, and I think the other day it said that maybe 15 to 20% of the total cost of a product here it's saying it could be 15 to 70% of the total cost generated in the company. All right, so it's not just of the product, but of the total costs of the expenditures in the company. 15 to 70% could just be in material handling. So that's the reason that that I mean that's some pretty big numbers. That, and so anytime we can make an impact there, then that's going to be a great benefit to the company and can give it a competitive edge. So the goals of material handling system, reduce unit costs of production, maintain or improve product quality, reduce damages, provide protection of material, promote safety and improve work condition, uh, produce, promote uh, productivity, promote increased use of facilities, and control of inventory. Okay, so getting into a material handling system design. So the first thing you want to do is a material handling system design is define the objectives and scope. All right. Now, I don't know if you guys and girls have been through much, problem solving, or project management techniques, whatever. But this is very standard. For anytime you're taking on a new project or a new project or whatever, you want to make sure you define the objectives, and particularly important, define the scope. Okay. So once you got the objectives and scope identified and agreed to by all the stakeholders, next one is analyze the requirements. Okay. Uh, and we'll go through a little chart here to kind of show you how it can be done. Then you want to generate alternative designs. The thing used in the industry that I find very useful, it's very popular in the industry, is a process called the 7 ways. And I'll introduce you to that here shortly, if you don't already know it. And then then after you get the 7 designs, then you want to kind of evaluate them or score them, and that's when the Pugh matrix comes in, how to decide which design works best. Then based on hopefully quantitative and subjective, but still you got some numbers here, kind of back it up. Select the right solution, and then you want to implement. All right. So this is how you would do a material handling system design, and even whether it's a large scale or a small scale. If it's just one assembly line, or just connecting 2 or 3 pieces of equipment, whatever, you want to go through the same process there. Um, so you want to make sure you want to try maintain the discipline to go. Don't just jump and just like many companies do or whatever. Just go out and buy some material handling equipment without really analyzing and looking at the alternatives. And then sometimes you find out actually maybe the buying equipment is not exactly the right answer or what you really need to do. Okay. So material handling system design, and the key is what you're doing here. You're looking at the materials, plus where are the moves, uh, distance, where it's going to, and then the method, and then so the materials plus the moves plus the method, that gives you a system. Okay, so that's what we want to do. Is come up with a way to make it where it's not just ad hoc or just pulling it out of the sky. Is a systematic way to help identify what's the best material handling system or method to use in any application. So a framework for identifying material handling solutions. Um, One that we're going to go over today is called a material handling planning chart. Uh, One thing you want to do in the any material handling is work simplification. And we'll discuss that more as we get into the lean operations. But whatever we want to do, we want to work simplifying the material handling. And what we want to do, what we'll do on the material handling planning chart is that we'll evaluate each movement. Like, can the movement be eliminated? Can the move be combined with another or within a in transit operation? Can it be? Can the move be simplified? Can the sequence of move, be changed to to advantages? Okay, so this is just some of the items that we'll be trying, be looking at as we go through the planning chart. Okay, so here's a sample of a planning chart. Quite busy, and I'll just kind of step you through each column here. But okay, when you're doing a material handling chart, you want to record all movements of people and machines. And what you were trying to do definitely is reveal unnecessary movement and storage. All right. Again, we'll get into the lean operations. We'll cover this heavily. But right now, we're just covering, really how to actually do to compile a material handling planning chart. So on this chart, you just start off with the first, the first column is step. So this is just, just numerical order of the steps. And steps breaking down like every time. I mean, a step's not actually a movement. It's just, it could be a storage, it could be a movement, it could be a operation. So that goes in the next one. Next is the activity. So an activity here, we got OTS. You can see at the bottom left there, the kind of little legend that O means this is an operation, T means the transport, transport, and S means storage. All right. And then whatever the activity is, you just put an X under there to represent. Like the first one there, says that it's a X under S. So the first activity is a storage. Then activity description, like the first one there is sheet metal stored in a cantilever rack. Okay, so this is actually just a storage location that starts this process off. Okay, the operation number, some companies will have this and some won't. The operation number would definitely should be linked into the manufacturing router. So a lot of times on a manufacturer router, you'll have like step O10 will be the first step. The second manufacturing transformation step would be like O20. So this operation number, these are our operations that are actually transforming the raw material or material into a product. Okay. So again, I mean, this is not necessarily, unless the company is using routers and they have operations numbers, and I can tell you not all companies have it. It's a good thing to have, and particularly even tied into the bill of materials. Okay. Next category is just department. This is just this is all up to, this is, company specific, what they might call a department. So, here, first one, the sheet metal is being stored in the metal fab area. You see that on the second one there, it says material handling, MH. So that actually is typically when you see that material handling MH, that's going to be a transport. That means that material handling, team function, whatever, is moving the item. All right. So that all of those covers the where. Okay. So where is material at? All right. Then the next area we cover the what. Okay. So, what container type. If you can see down here, I got, I got pallet, I got number 06, number 10, number 40. And, all companies should, you should create one. This is a legend of the different containers that you have in your company. Okay. So, if you say it's a '06, then, it should be kind of common knowledge in that facility what a '06 is. Now, we do also, whoops, what it, so I did. So next to the '06, I do have a dimension just for reference. But if you had a good container standardization or container identifier system, you wouldn't have to put the dimensions there for a standard container. Okay. Then quantity container. So, based on the part you put in there, how many parts can you put in there? And then, based on the number of parts you put in there, what is the weight? Okay. OSHA has a limit on how heavy a container can be for a operator move. Uh, Actually, I think it's 50. Uh, I've seen companies that use 40. I think maybe OSHA might be 50, but anyway, anywhere if you get in the neighborhood of 40 or 50, that's actually getting too heavy for a operator to move. Excuse me, without some type of material handling assistance. So the wind, okay, gets the frequency that it's moved and how far is it moved. We got the where it's at, what it's going to be put in to move, and when, so the frequency, distance, and then the last one is the material handling methodology. All right, so this is just this is where you really start getting into, okay, what's the best way to go? A forklift, uh, you know, uh, you know, like here I got shear loaders, so this is actually automation that help you load the shear instead of manually loading the sheet metal into the shear. You got pallet forklifts, and probably a couple modules away, but we'll go very deep into the different material handling type of equipment. But this right now, I'm just going through kind of showing the evaluation forms to go through to help you identify what your material handling design should encompass. Okay, so I mentioned 7 ways. So 7 ways is a method used to encourage creativity to generate multiple solutions to meet a customer need. Customer need, this definitely refers to internal and external customers, but most of the time you're probably talking about maybe internal customer, which a lot of these cases here could be production. Um, so 7 ways evaluation tools used to show at a glance 7 potential solution ideas. You typically create it by brainstorming. Uh, it's a useful tool in a situation that needs a team to choose between several options. This is a wonderful tool used when you're doing a new layout, looking at a different processes, what type of equipment to buy, what kind of systems to implement, what kind of methodologies. Um, so a little bit, 7 ways. I mean, why 7? Why not 3? Why not 10 or whatever? So it's typically, been found that when you do 7 ways, the first 3 are probably very, very simple, and maybe might even be not really that creative. Uh, and then you start getting into the fourth and fifth, and then you start seeing typically a lot more creativity, because you're really stretching it there. You're really going outside the box. And then you get into 6 and particularly 7. You're totally out of any new ideas. You say, oh, there's no other ways of doing it. Okay, so six and maybe seven, or seven for sure, maybe six, you're going to be stretching it. You're really going to be testing your creativity. And so what usually happens there is that six and seven, or where you really think out of the box. Okay. And most of the time when you come down to picking a solution, it probably would not be six or seven. But what happens very often is when you do six and seven, that kind of gets you thinking, and it makes you change number three or number four. All right. So typically, after you do the seven ways, the solution you come up with might not be any of the seven, but you're taking the good pieces of the seven to make it. All right. So that's the reason, the seven ways is to actually really challenge you to be creative and to challenge you to think out of the box. Now, this seven ways, again, doesn't just apply to material handling system. It applies to, actually, best way I ever seen it used is in layouts. You do a layout, everybody has an opinion. All right. So the best way to kind of narrow those opinions down is doing the seven ways, doing it as a team, brainstorming, and getting a consensus. Okay. So I introduced in this tool in this course just because I think it definitely applies to material handling systems, but also I'm hoping to give you something that you can use as you move out into the industry. A tool to be able to compare different ideas, different solutions. Now here's the seven ways. Actually, this is a kind of material handling here. Uh, and these forms, you can see this one here was just sketched up. Uh, this was done in the Kaizen, and we'll discuss briefly what a Kaizen is. But so it was a brainstorming session here. They came up with the different, the different ways of doing it, process method. They, looked at how could they build in some, you know, uh, go no go gauge or pokeyoki. What kind of tools will be done, and then what kind of jigs and fixtures would they need to make it happen. So and so this is just an example of seven ways. The one I showed earlier here, this is actually this is again a seven ways, but it's looking at different ways. Actually, this is how to transport material between different departments, but it's just kind of this is at a pretty high still concept level. This one here, we're actually getting into design and what it could look like. Right. And also seven ways. There's a Toyota system that came out. It's called 3P. Uh, it's production preparation process. And that's actually where I guess the seven ways kind of got it started. Start was, and really talking about thinking out of the box, and also during a 3P event, you actually you would mock up a design. So you try to do the design out of cardboard or whatever you had, just to see how it looked and worked. Okay. So anyway, that kind of goes a little bit heavy into the seven ways, but again, I think it's important to to have this knowledge. That a good way to compare is the seven ways. Now, once you get the seven ways, then what do you do with it? I mean, okay, yeah, I got my seven ways. How to determine which one's the best? Right? So that's where you get into the Pew matrix. It's a decision matrix to help business analyze, business analysts and stakeholders evaluate options. Um, so what you have is like this particular one. This is a real one from a project that I just did. Uh, Here we actually we have six different options that came up with. Um, so we actually had, I think we had about nine. We did more than seven ways, but we had about nine, and then kind of cut it down, to get the stakeholders involved. But you go through, and like you got on the left hand side, you got the key uh, criteria that you want to grade against. Uh, This actually was a a material handling situation here. So we had space requirements, transportation distance, non-valued added activities, uh, inventory levels, inventory controls. Uh, so and then each person would actually rate it. If it's equal to the current process, it just gets the equal. If it's better than the current process, it gets a plus. And you can go up to, I mean, well, I got to put the 4 on here, but you can set the rules any way you want to. How many pluses and how many minuses you can have. Okay. Then you go through and total it up. At the bottom here, you see option C1 has 10 pluses and 1 negative. Option A2 has 7 pluses and 0 negatives. So part of the kind of the rule of thumb for a poo matrix is that you don't want any negatives. So actually, the rule of thumb would be because option C1 had 1 negative, even though it had the higher pluses, that you should go with option A2. All right. I can tell you in this particular instance, I went with option C1 because the 1 negative was actually was it was a business decision that could be overcome. So anyway, so this allows you to come in and get a quantitative. I mean, it's subjective, but I guess you kind of quantitating it. Plus, you're getting a consensus of the stakeholders and consensus of the group. This is the way to go. Now, here's another just example of how to do a 7 ways evaluation criteria sheet. So here you got your 7 ways at the top, and then you just list down different criteria. When I do one like this, I will always have safety at the top. Okay, and then like on this is just an example, but you see the next one. This is also a material handling situation, but you got safety. Next one is the overall layout. Uh, then you got a put away process of how you put materials back into the warehouse or wherever. This is looking at the a kitting process, a kit pulling process, and then a key one here is space analysis. Um, so this would be same thing. You go through the pluses and minuses, and you total it up, and then this will help you evaluate which way is best. Okay. So again, this is just a example of a 7 ways sheet. Okay, the next thing we're going to cover is unit load. If you remember back in the 13 principles that we went through, one of the principles was you having a unit load. So a unit load is a unit to be moved or handled at one time. The unit load includes, it could be a container, a carrier, or support that will be used to move materials. The unit load is the unit to be moved or handled at one time. The unit load includes a container, a carrier, support that will be used to move the materials. Examples of unit load could be tote boxes, cassettes, uh, cartons, skids, pallets, pallet boxes, intermodal containers, like particularly sea or interdivision or truck containers, or 1 unit of a product. So a unit load is what you can use to move 1 unit of material, and a unit could be more than 1 piece though. So the most popular type of unit loads or plastic containers, and just the normal forklift type of pallets. So the factors for determining a unit load container, there's going to be the size of the carrier. I mean, what you need, what kind of box, or what's the size of the actually item, the size and the weight of the items, space for storing loaded and unloaded container, equipment for moving it, call supply maintenance, your owl width, store lifts, clear stacking heights, and then of course environmental regulations. So here's just a simple, you look at a unit load. So error kind of shows a flow here. So in production, so the production batch that we're showing here is 16. All right. So the batch it makes on the machine is 16 at a time. Okay. Then the transfer, the number of pieces that actually gets transferred to the next workstation is 8. So it's 2 batches. Okay. But the unit load is actually what goes to the operator or to the assembler or whatever. So the unit load is actually 4 pieces. And then the operator pulls out a single piece. All right. So the unit load here is 4. So you can see here is that the machine is processing, what's equivalent of 4 unit loads. The transfer batch is actually moving 2 unit loads at a time, and then the unit load is actually, so one of those are actually being put at the workstation at a time, and then the operator is actually pulling one piece out of the operation at a time. Okay. So I just looked here, and we're into 37 minutes here. So got a few more slides to cover on the unit load. Trying to think. Probably best to go ahead and cover those. Everybody's okay with moving on? Cover about 6 more slides. Any objections? All right. So the unit load and material handling on system design. The unit load is an integral part of material handling system, and simultaneously determination should be made. Okay. So when you're designing the material handling and storage system, you definitely also got to be designing the unit load. It's not, you don't design a unit load, without thinking, downstream or upstream of what the handling and storage system is. So these are, it's got to be a very integrated decision to what the unit load is. Okay, so you're creating a system here. Okay, so you don't want to, be moving stuff in and out of containers for no reason. So if you can come up with like a unit load on the machines, you do everything in 4s, and then that 4 goes all the way to the operator. All right. So when you're doing the design of the system, you've got to think about the small pieces too, and how all they interrelate. Just they got the thing about Ford trucks in the factory. How does unit load come off affect your transit, your shipping, and how can it affect your distribution and even going to the retailer. So one of the last little things to cover here is just you're going to go through a little exercise here, to actually calculate the unit load and cycle time. All right. So the situation we have here, so we have a system with 2 machines. So operation 1 and operation 2. So each unit of the product must go through operation 1 first, and then it goes through operation 2. All right. And it has to be moved between operation 1 and 2. Okay. So we moved the product using forklift trucks. This scenario we have here, the company has several of them, going around permanently. So you're not having to wait for forklift trucks. So, it's pretty convenient. So then we can, so anytime you need a forklift truck, you can get one. So to move from machine 1, machine 2 only takes 2 minutes. So the forklift truck moves as a batch or a lot of units at a time. Okay. So and really that kind of boils down to what the unit load will be. So how many units should we move at one time using the fork truck to minimize the completion time of an order of 16? Okay, so that's the problem that we got resolved here. So how many units should we move at one time using the fork truck to minimize the time of completion of an order of 16 units? Right. So um, so in other words, how big should a unit load be to minimize completion time? Okay, so what was the assumptions that we're dealing with here are the lot size of 16 units, machining for each operation, 1 and 2 is 1 minute, and the material handling time is 2 minutes per trip. All right. So we got on the left here, we got 4 situations here. Okay, so one is the unit load is 16 units. You got to do 16 at a time, and then you want to do one material handling, and then you do 16 more. Okay, so that takes 34 minutes to complete. Get all 16 units through the cycle. The second one here, we come up with a unit load of 8. And then with unit load of 8, you'll have 2 material handling moves, and the total time is 26 minutes. Excuse me. Okay, and then the third scenario here is your unit load is two units. Um, so your operation 1, you're doing 2 units at a time. Material handling, you're doing 8 movements. And then operation 2, you're doing 2 minutes of the load. So to process 16 units is 20 minutes. All right. And then the last one here is a real single piece flow where you do each one individually, a unit load of 1. Okay, but then you can see the deal here is that every time you do 1, it takes you 2 minutes to move it. All right, so your transport time on this is 2 times 16, which is 32. So your assembly time doesn't change really. It's just now you're spending 32 minutes of movement. So large unit loads equal longer cycle times but fewer moves. Okay, but if your material handling time is greater than your processing time, then your material handling is a constraint. So the only time we really see that here is on if we go to a unit load of 1, then our material handling time is greater than the processing time. So then the material handling definitely is the issue here. There in that situation. Okay, so this is looking at by the picture here, by doing the graphs here and everything, it looks like the quickest way to process 16 units and move them between the 2 different operations would be a unit load of 2. Okay, now to mathematically determine that, you got L equals to the load size, PT, which is unit production time. You got TT, which is the transportation time. So to calculate it, you got the load times the process time equal the transportation time, or the load equals the transportation divided by the production. So we got a production time of 1, a travel time of 2. So the load actually comes up to be, it comes out to equal to 2. All right. So, the little graph, or not graph, I guess you could call it graph, or the diagrams on the left says that it should be two. That would work best. The mathematics says two, and then actually got a little. If you really sit here and just plot it, you can see that the graph shows that the lower number is or the unit load times that gives you the lowest completion time is two. All right. So that's a kind of very simple way, but it's a good way to think about it. And actually, this is very important. And actually, this is something we'll do in material handling, we do it in lean processes, and we definitely do it in manufacturing. Is think about the how long it takes to get the whole batch, a whole lot through the process. Uh, so one last concept I'll cover here. Uh, this actually is kind of a little bit off maybe of the material handling system, but it actually it ties into the unit load there. But it's a concept again. It's something I want you to have knowledge of to take with you if you're not already familiar with it. This actually came out of my lean building blocks slides on a flow, but we've got something called Little's Law. Okay, so Little's Law in process time. So actually, a lot of times, Little Law be identified as a queuing theory. Okay, so a discipline within the mathematical theory of probability. So Little's Law is a theorem done by John Little, which states that the long-term average number of customers in a stationary system is equal to the long-term average of the effective arrival time multiplied by the average time that the customer spends in the system. So Little Law is equal to is the number of customers in the queue will be equal to the how fast they arrive, and the W being how long they spend in there, or which is also the exit rate. Okay, so this is a queuing theory. But what it kind of means in what it really means into the unit load we just talked about and to the material handling, uh, you know, it's a mathematical equation for calculating lead time. So so forget all the really in-depth studying or whatever. It's just your lead time is equal to the number of units in WIP divided by the average production time. So the lead time, if we had 16 over there, okay, and it took 1 minute per, then the lead time was 16. Right? So then if we had the we had one piece, and the your whip of one piece, like a unit load of one, and the average production rate was one, the lead time would be one. Okay, but then we also on the other study we have to factor in the material handling time. But the importance I want to share here is that the amount of whip or the amount of batch sizes definitely has an impact on the lead time. Okay. So that's the reason you hear, in lean terms, they'll say single piece flow or whatever. Okay. So single piece flow, but we just showed single piece flow when when you incorporate a material handling, actually one piece flow is not the best way. All right. A unit load of two was the best. All right. So it's, you want to look at lead time, and then you got to factor in the material handling time, which I think is important factors to think about in terms of lean, and also as we move forward. Okay. So let's just say if you had 34 items in a working process, you produce 10 per day. That means it'll take 3.4 working days to make it through the system. Okay, so this is very important, to think about your unit load, how much time it's going to be. You're going to tie up everything else, how much you're going to increase the lead time, but then also think about how to optimize the material handling time. Um, and one just the in case if the little law seems difficult for you, probably for most of you not, whatever. But you think about Starbucks. How long it takes you to get your coffee is the number of people in line versus the number of people served, or sorry, people served per minute. So you got 11 people in line. It takes them 1 minute to get the order. Therefore, it's going to take you 11 minutes to get the coffee. Pretty simple, okay? But that's what Little's law is. Okay, I'm not gonna. Actually, I'm going to stop there because um, next time we'll get into a little bit about a couple of tools. Um, So I'm going to change the flow of the course around a little bit. I am going to go ahead and next time cover material handling. Sorry, cover assessment tools, the value stream mapping, a little bit about Kaizen, a little bit about